Good morning. 7.5 similar triangles and indirect measuring. We're going to be talking about being able to find missing angles, identifying similar polygons, writing similar statements, calculating the missing sides and angles of similar polygons. And then we're going to be talking about indirect measurement and similar triangles. So first, angle, or AA similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar.
Mr. Peters, can you please call
So,
extension 3003 or come to
if
the office?
A
Thank
is
you.
congruent to F, so this would be angle F, that's because I have one arc here and one arc here. And angle B has 2 and angle G has 2. Then triangle ABC is similar to, and we would start with the same one. So if we start with A, we start with F. So F, G, H, triangle. Okay, so taking that and knowing that, and we can find then our unknown lengths. So first determine whether the two triangles are similar, and if so, write a similarity statement. So we have to look here. Angle G is unknown, but the measure of angle G is, we should be able to find that out, right? Because we can do 180 and subtract our known values of these two. So 62 plus 48. So this equals 110. If I subtract that, that equals 70. So this one is 70. Okay, then we can see that, so angle E is 62, angle G is 70. If this has got to be 48 then. So because they're all the same, we can write our similarity statement. So doesn't matter, we want to start with any letter. So E, G, H is similar to, so E is the 62, so I'm going to go with triangle A, and then I went to the G, which is the 70, so C, and then B. Okay, as long as making sure I wrote the 62s first, and then the 70s, and then the 48s. Now if I would have went A, B, C, this would have changed also. It doesn't matter which one you start with, as long as you start with, if I start with the 62 here, I have to start with the 62 here. Okay, now determine whether the triangles are similar. So if I have 110 here and 110 here, this right here is a vertical angle. And if we remember, vertical angles are equal. So I'm going to put one arc on both of them. So if these are equal and these are equal, they've got to be similar, because I only need two angles that are the same, and I have one here, so these two are the same, and these two are the same. So I'm going to write my K first, so triangle K, and I could even do similar to triangle K. Then I'll go to the 110H, and this one does. We'll put L here. So L, right, next, and then J and M. So this is our similarity statement. Okay, so next we're going to be talking about indirect measurement. Indirect measurement. It's a technique using properties of similar polygons to find distance or lengths that are difficult to measure directly.
Can I please have Kanaya Thompson come to the office? Kanaya Thompson. Can I have the following students to the atrium at this time? Ayana Johnson, Angela Mar Soto Arbello, Haley Wright, McKenna Virginal, Jessere Gonzalez Hernandez, and Jamale Pabon Santana. Please go to the atrium at this time. Thank you.
Okay, so shadow reckoning is a type of indirect measurement that uses two objects and their shadows to form similar right triangles. So first you're going to write the proportion using the corresponding sides. Solve the proportion, and then don't forget always to label your answer. Oh, you can't see that, can you? Sorry.
Good morning, Mrs. Hafner. Could you please call extension 3003? Thank you.
Okay, so our last, I believe, two examples. We have a fire hydrant here, 2.5 feet cast high, right here. High. Oh, a fire hydrant, 2.5 feet high, casts a 5-foot shadow. So right here, 2.5 feet high. How tall is a street light that casts a 26-foot shadow at the same time? So let H represent the height of the street light. So right here we have 2.5 feet, and this is going to be 5, so it's 5. This shadow right here is 5 feet. So we're going to use these two because they're similar. We can set up a proportion. So I'm going to take the 2 from here, so 2.5 and over 5, and set it equal to, so the 2.5 is the height, so the height is going to go, remember, want to have something in common here, and then 26 here. So we can cross multiply, and we would do 2.5 times 26 gives me 65, and it equals 5 times H. Then I can divide by 5, H is equal to 13. Now, just looking at this real quick, if you see that it's 2.5 and then if you double that, you get 5, what doubled is 26? Well, 13 is. So we can also use logic like that. Don't forget to label. So this would be 13 feet. Then find the distance from the house to the street. So right here we're looking for, so this is our house and this is our street. If we know that this is 4, these get a little tricky because we have to show, like, so if this was 3 arcs, and this is 3 arcs because these are our vertical angles, so between the 2 and the 3, so this 5 has something in common with our unknown D. And then we do know our 8, but we have to put the 8 with the D because it's in the same triangle. The 4 has to go with the 5. Okay, I want to solve my proportion. So I have 4D equals 5 times 8, which is 40. I can divide by 4 on both sides, and D is equal to 10. We want to make sure to label. And I think that's the only one left on. Yep. Okay, your assignment. Can't even see it. Come on, page 557. Oh, there we go. 1 through 7 odd, 15 through 21 odd.